This is the second video in my Casting Shadows series, and it's about the basics of shadow casting. It's in my book, Ellen's Guide to Casting Shadows, on Amazon, where the Kindle is only $5. The basics of shadow casting is the light triangle, which gives us the relationship between the light source, the pole, and the casting surface. And to do that, we draw a vertical line from the light, and where it hits the casting surface is the vanishing point for the shadow. And lines from this vanishing point go through the bottom of the pole, while light rays go from the light source through the top of the pole, and where they intersect is the end of the shadow. If the light ray is nearly horizontal, then we get a long shadow, which is typical of sunset. If instead it's more vertical, then we get a short shadow, which is typical of noontime. If the pole is in the air, then the light is tangent to both the top and the bottom of the pole, and where they meet the shadow line defines the length of the shadow. In this picture, I made one of the columns the pole and found the end of the shadow. And when you connect that end of the shadow to the top of the pole, you get the light direction. In this situation, the shadow direction is horizontal, so the angle it makes with the vertical is a 90-degree angle. Most of the time, the shadow direction isn't horizontal, and there are two main types: backlighting and front lighting. With backlighting, the light, or the sun here, hits the back of the pole, the part we don't see, and the shadow comes toward us. And the pole itself is in shade. For front lighting, the sun is behind us and hits the front of the object, so it is light, and the shadow goes away from us. When we don't look at the sun rays are parallel, so the shadows are also parallel. And here we connect the rungs to their shadows on the ground to find that the sun is in the upper left and the light rays are parallel. So the shadow lines are either parallel or converging. With parallel sun, the proportion of the height of the pole to the length of its shadow remains constant. So let's look at this pole, and let's say it's like 1x, and let's say this is 1.5x. Well, then if you go to this distant one, this is still 1x and 1.5x. In contrast, sun rays radiate out when we look at the sun. In this situation, you can see that there's radiation of the shadows. And these shadows converge toward a shadow vanishing point on eye level, which is also on the horizon. And directly above that is the light source, where sunlight hits the top of the pole to reach the end of each shadow. This is front lighting, where we're looking at the pseudo-sun, so we have radiating shadows. And let's try to understand this picture. First, draw the shadows so that we can find where they converge at the shadow vanishing point, which is on eye level or the horizon. And then directly below that is the pseudo-sun. And where it is exactly is on the head of the shadow of the viewer's head, where the viewer's eyes would be. So that's the position of the pseudo-sun. If this person just turned around and looked up, he or she would see the sun. Artificial light is totally different from sunlight. So here we have the lamp, and vertically below is the vanishing point for shadows, which is on the ground, not on eye level as it would be with sunlight. And the lines go from this shadow vanishing point under each of these poles, and where it intersects light that hits the top of the pole is the end of the shadow. And some of the characteristics are that the shadows radiate out from this shadow vanishing point. Their shadows are different lengths and different orientations, And you can see all kinds of lighting. Like this is front lighting because the light is hitting the front of the pole. And this one here is backlighting because the light is hitting the back of the pole. Let's go through some examples. So here's the light, and here's the vanishing point for shadows on eye level. So this must be sunlight outdoors. And the light goes through the top of the pole, and the shadow goes through the bottom of the pole, and where they meet is the end of the shadow. Now the second one, the shadow vanishing point is again on the horizon, so this is sunlight, and a line goes through the base of the pole, and the light goes through the top of the pole, and where they meet is the end of the shadow, and this part is the shadow. And this is backlighting because it's hitting the back of the pole. This next one is again sunshine because the vanishing point is on eye level. So this pole must be in the air, meaning that both sides are what I call floating ends that are not attached to any surface. And so light would go past both of them. And in this case, I'll just choose a shadow direction like here, for example. And so where the light meets the shadow line would be the shadow. And then the final one is artificial light because the vanishing point for the shadows is on the ground. And you just send shadow lines through the bottoms of these poles and light rays through the top to find the ends of the shadows. In this video, I showed you 3 types of lighting. The first is radiating sunlight, where we see the vanishing point for the shadows and the light, and the lines through the bottom of the poles from this vanishing point goes to the end of the shadow, and light rays pass through the top of the pole to meet at an intersection. The next one is parallel light rays with no visible vanishing point for the light or the shadows. And since the light is parallel, the shadows are either parallel or converging toward the same vanishing point on eye level. And then the final one is artificial radiating light. And the vanishing point here is on the ground, not on eye level. We know eye level must be about here because we're looking down at this table. Here's a summary of this video where I compared radiating sunlight to parallel sunlight and radiating artificial light. My next video in this Casting Shadows series will be about shadows of a horizontal pole. And please remember to subscribe and check out my book, Ellen's Guide to Casting Shadows, on Amazon, where the Kindle is only $5.